Alright guys, Chapter 9, Section 2. Some similar ideas as Section 1. Instead of estimating the population proportion, we're estimating the population mean. Now originally they had talked about in the book where we'd use this formula here when we're using a z value and we know the population standard deviation. But if we know the population standard deviation, shouldn't we know the population mean? We should. And so this guy came about and is like, well, I'm going to make this different distribution that works for smaller samples, and I don't know the population standard deviation. He actually worked for Guinness, so what a great job. But he finds the student distribution. And so that's has a similar picture and feel to the normal, but just a little bit different. If we go look at StatCrunch, they're asking us to find t-values so that the area in the right tail is 0.005 with degrees of freedom. Degrees of freedom is your sample size minus 1, so n minus 1. So if I open up StatCrunch, we can find out this information by going to Stat, Calculator, but we're going to look at a t-calculator this time. And so again, it looks very much like a normal model. It's just a little bit, it's either wider or I think it's wider than the normal model. So here our degrees of freedom are 5, and I want the area in the tail to the right to be 0.005. I think they said greater than. And there's our value. That's our t-value, 4.032. They probably say 4.0322. Let's see how many they're looking for. 3 decimal place. 4.032. And so that's how you find t-values for these things. It works the same where if you wanted to go in between, you could do that. Again, you just have to type in the degrees of freedom and either type in, if you're looking for the area to the left or the right, you would type in that area here, and again it'll give you out a value, and you can do the less than or greater than. So that's how you find your t-scores. Very similar to z-scores, except we do not know the population standard deviation, and so it's a distribution that works for us with not knowing the population standard deviation. But let's go back to our homework and let's look at these confidence interval things. When you're doing a confidence interval for a mean, here I'm 90% confident, so I have 659 customers. Oh, and they're actually giving us a confidence interval here, so that's cool. That's a different type of question. Clicked on the wrong one. I want to find here's how we create a confidence interval. So this one's asking for a 95% confidence interval. N is 34, and we took a sample and we got 19.2. So our sample was 19.2. The mean was, and we sampled 34 people, and the sample standard deviation is 4.8. So that's the information that we're going to need to find our confidence interval. So again, very similar to the proportions from the last sections, except now I'm going to go to t-stats. So section 1 I went to proportion stats, section 2 I'll be using t-stats. Now I'm looking at one sample, and this has a summary. Again, if I was given 34 numbers, I could just stay with data and tell it where it was located. But we're just given a summary of information. The mean was 19.2 and a standard deviation of 4.8. 19.2 and a standard deviation of 4.8. And my sample size was 34. And I want to find my confidence interval. So I'll click on confidence interval, and this one was 95%. That is a common one. So I get 17.53. Let's see how many spaces they want. 2 decimal places. So 17.53 to 20.87. I'm going to forget that, but I'm going to try 17.53 to 20.87. And so that's how we find a confidence interval about the mean using the t-distribution. So again, the basics, the idea of it the same. I am 95% confident that my population mean is going to be in between 17.5 and 20.87. Again, we just happened to find that our sample mean was 19.2, but that doesn't mean that the population mean will be 19.2. But I am 95% confident it's going to be in between these values. Have a good day.